So welcome to the tutorial on how to build the Oregon shaped board. Before we get started, let's make sure that we're comfortable with the safety issues involved in this. We want to make sure that you stay safe, so we want to make sure you're working in a well-ventilated area or using a fume extractor or a fume hood of some kind, that you're wearing safety glasses of some sort, and that you're aware that the soldering iron is very hot. Know that you're also working with lead-based solder. Lead-based solder, you need to wash your hands before you go do anything else. Okay? So before we get started again, let's take a look at this user's guide over here. The user's guide is available on the Oregon Tech website, and it basically outlines a lot of information about the board. Safety information, parts. We're going to go through parts. We have schematics, we have how to assemble the board, right, how to put the components in place. It's essentially the paper version of this video, but with even more information. It'll show you how to solder, or a proper solder joint, how to fix some issues. It'll have the schematic, which outlines all the components that you need, or how they're connected and arranged, as well as a bill of materials, which outlines all the materials you'll need to build the OWL board. So for the board, we also have Arduino pin mappings for the software, and we have instructions on how to essentially install the software, install the drivers, and do a basic blinking example. So check that out when you get the chance. So back to the board. Okay. So let's start with the resistors. Resistors are not polarized, so we're going to start with 330 ohm resistors. These 330 ohm resistors are orange, orange, brown, gold. Orange, orange, brown, gold. And they're going to go in slot R7, R1, R2, R14, R13, and R12. Oh, actually, it's not going to go in R7, so I take that back. Again, they're not polarized. You can insert them in either direction you want. So let's start by pushing this one in to R1. On the back, I'll flip it over and I'll bend the lead so it doesn't go anywhere. Okay, so I've gotten all the resistors I said I was going to get in. Now we're going to move on to the next resistor, which is either a 10K or a 1.5K. I'm going to go with the brown, black, orange, gold resistor. And these go into 3 different spots. You'll need 3 of these, which is R4, R6, and R7. The only 2 spots for resistors left are R8 and R9, and the 2 resistors that go into that spot are the blue, gray, black, and gold resistor. So I believe we've put in all the resistors needed. Let's go ahead and solder all the resistors. Remember again, when we're soldering, it's lead-based solder. It may be lead-based solder. So wash your hands after you solder. Make sure that you're aware the iron is hot. So let's go ahead and start soldering. Let's zoom in a little. So there's 2 holes here. What you want to do is fill in the hole so that it looks like a Hershey's Kiss almost. If it starts to look like a big circle or blob, you're not doing it right. It's too much solder. Remember to work in a well-ventilated area or use a fan. You may wish to also use helping hands or something to hold the board. I tend to like to not hold it in a vise or some sort, so I'm just holding it without. I'm essentially holding the board, not holding it. Okay. So let's see here. We'll fill in some more solder over here, 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 here. When you're soldering, you want to touch the lead and the pad. Remember, you want to touch the pad of the board and the lead of the component. And what we can do now is go back and trim all these weeds. The weeds tend to go flying, so try to hold on to them and make sure it doesn't hit anyone. I guess I missed 2 resistors over here, so we'll just go ahead and fill in the solder. And I'll trim the leads. The board gets hot as you work on it, so don't touch something you've soldered right away necessarily. It can get hot. Okay, so I think we've put in all the resistors. What should we do next? Well, I'm going to do the buttons next. So there are 2 buttons on the board. They snap into place over here. However, when you're putting in the buttons, make sure, I'll show you right now, you see how the buttons have the tabs coming off to the side? The tabs should go in this way. If you have to force the button in, then you probably should not force it in. It's probably oriented the wrong way with the tabs coming up. The tabs are coming up or down, which is not good. So you want the tabs coming onto the left and right while you're looking head on at the state of Oregon. So just push this in. Okay. We'll go ahead and solder this into place. Okay. So the next 2 components I'd like to put on are also, the orientation doesn't matter. We're going to put capacitor C1 and C2 on the board. And I'm just going to place it in. They're ceramic 1 microfarad capacitors, and it doesn't matter the orientation of the part. Again, I'm just going to go onto the back of the board and bend the lead so that it stays in place. And while I have the rest of the board there, what I'm going to do is probably grab and put the LEDs in as well. So the RGB LED, as well as 2 regular LEDs. So for the regular LEDs, you'll notice that there's a flat side. However, on camera it's really hard to notice. So the flat side of the LED goes to the flat side on the board. You can see the flat side of the silk screen. Or you can take a look at the leads. The leads are 2 different lengths. The longer lead goes away from the flat side, or the flat side goes towards the lead that's shorter. Okay, so short side to the flat side. Shorter lead to the flat side. Again over here, shorter lead to the flat side. And again, I'm bending the leads so that we don't have to have the components fall out. And we have an RGB LED as well. On this RGB LED, there's going to also be a flat side, but it's kind of hard to notice as well. So the easiest way to just put it in is to look for that flat side. This is the flat side. 2 away from the flat side should be, or 1 away, or 2, actually 2 away from the flat side should be the longest lead. So the longest lead should go into the second hole from the flat side. And I'm just going to place this in. This component can be a little trickier because the spacing is a little bit small. I'm just going to push the lead through, and then I'm going to bend 2 leads just to keep it in place. We're going to come back onto the back, and I'm going to start soldering these components into place. Oh, and I forgot this one. This one's pretty easy to bridge, so you might need help. It would be great if it was in frame. Since that was out of frame, let's do that again on another board just to make sure you can see that. So again, longest lead, second hole from the flat side. Bend the leads on the board so that the LED doesn't move, and then we're going to solder it. The spacing on these holes are pretty small. You may need help, or you may bridge them. And I'll show you what to do if you bridge them. Alright. Doesn't look like I bridged them. However, let's pretend we did. Let's bridge them on purpose. Oh no, there's a big blob. What do we do now, right? So, there's 2 ways. Sometimes you can just clean your iron off and drag it, and it'll remove the excess solder from the hole. Sometimes you'll need a roll of braid, solder braid or solder wick, and we'll just put the solder wick. Oops. Solder wick does get hot, so make sure you don't touch it. And we're just going to heat up those 2 pads while the wick is here, and it should help us wick away the excess solder. I believe if we look at that close up, it should no longer be bridged. I believe now that we can go back to our normal board, and I'll finish trimming the leads on it. only components left are the surface mount components and the microcontroller. So let's handle the surface mount. There's a surface mount fuse over here. So I'm going to grab the fuse with the tweezers. The fuse is not polarized. I'm going to heat up one pad. I'm going to lift the fuse up, and I'm going to heat up the pad, place the fuse in, let go of the soldering iron, or let go of the pad with the soldering iron, and then come back to the other side, making sure you don't burn your LED, because it's pretty close. And we're just going to heat up that side, and we're done with the fuse. The next thing is the regulator, the voltage regulator on this board. Also uses a surface mount component, and it is right here, U3. U3 is going to fit with this part. Okay. Now what we're going to do is apply solder to the main pad, the bigger pad. Okay, and I'm just going to take this component, heat it up, making sure to leave enough room on the other side so that you can solder to those pads. Alright, so we'll just put some solder now on the other side. Remember, if things are blobbing up, you're putting too much solder. Alright, so the next thing is going to be the microprocessor. It is essentially the brains of this device. So I'll grab the microprocessor. And let's look at this carefully now. You see this notch up here. There's a notch on the silk screen that should match with the notch on the chip. So make sure that it's oriented properly. And then what we're going to do is stick it in. Okay. And then on the other side, I'm just going to bend the leads a little so it doesn't go anywhere. Okay. And we're just going to solder in place now. Alright, so we've soldered it in place. Let's pretend we had a bridge by accident. Let's cause one on purpose. Alright, we caused a bridge on purpose. How do we get rid of that? Sometimes we can just clean the tip, heat up the joint, and it'll go away. Other times you'll need the wick again. So let's flip the board around. I believe we're almost done. We have one more component left, which is the USB port. So I'm going to place the USB port in, flip the board around, and start filling in the solder there as well. Make sure you fill in these two holes pretty well. That serves as a mechanical anchor for the USB port. So I think we're done building this. Now, before you plug anything in, make sure that you have someone take a look at your board to make sure it doesn't have any shorts. Okay? Make sure that your board doesn't have any shorts. Again, we don't take responsibility for your computer. Again, the warning says we're not responsible for damage to your computer. We don't know how you soldered. We can't control how you soldered. We've done what we can to prevent damage, but we don't know what you're going to do. So let me show you what it looks like when the board is plugged in. So for this particular board, you need a USB cable. So I'm going to plug it in. Again, plug it in at your own risk. I'm going to plug this in, making sure nothing is shorting on the board. If you have a metal surface, a metal table or something, you should probably not do this on that metal table. Put something in between. And we'll plug this in. And on this particular board, nothing will turn on except for this LED right here, which is the power indicator. The Portland LED and the Klamath Falls LED buttons, nothing will respond until you program the board.